Hydraulic schematics can be a mystery to anyone who cannot identify the many symbols used in circuit diagrams. The purpose of this videotape is to show you most of these symbols, which will help you find your way around hydraulic schematic diagrams. Accurate diagrams of hydraulic circuits are essential to the person who must repair it. The diagram shows how the components will interact. It shows the field technician how it works, what each component should be doing, and where the oil should be going so that he can diagnose and repair the system. There are two types of circuit diagrams, cutaway and schematic circuit diagrams. Cutaway circuit diagrams show the internal construction of the components as well as of the flow paths. By using colors, shades, or various patterns in the lines and passages, they are able to show many different conditions of flow and pressure. Cutaway diagrams take considerably longer to produce because of their complexity. Schematic circuit diagrams, the shorthand system of the industry, are usually preferred for troubleshooting because technicians are doers rather than readers. A schematic diagram is made up of simple geometric symbols for the components and their controls and connections. There are several systems of symbols used when making schematic diagrams. They are listed as follows. ISO, International Standards Organization. ANSI, American National Standards Institute. ASA, American Standards Association. JIC, Joint Industry Conference. A combination of these symbols are shown in this videotape. There are differences between the systems, but there is enough similarity so that if you understand the symbols in this videotape, you will be able to interpret other symbols as well. Let's begin by examining the symbols for reservoirs. A rectangle with the top removed represents a vented reservoir, while a rectangle with top in place represents a pressurized reservoir. There are other schematic diagrams that show a slightly different version of a pressurized reservoir, but the symbols are similar and easily recognized. An oval with a short line on top or a rectangle with curved sides represents a reservoir that is pressurized. Lines connected to the reservoir usually are drawn from the top regardless of where the actual connection is. If the hydraulic line terminates below the fluid level, it is drawn all the way to the bottom of the symbol. A hydraulic line connected to the bottom of the reservoir may be drawn from the bottom of the symbol if the bottom connection is essential to the system's operation. An example of this would be if the pump inlet must be charged or flooded with a positive head of oil. We would position the reservoir symbol above the pump symbol and draw the suction line out of the bottom of the reservoir. Every vehicle or system reservoir has at least two hydraulic lines connected to it, and some have many more. Often the components that are connected to the reservoir are spread all over the schematic. Rather than having a lot of confusing lines all over the schematic, it is customary to draw individual reservoir symbols close to the components. The reservoir is usually the only component symbol pictured more than once. A hydraulic line, tube, hose, or any conductor that carries the liquid between components is shown as a line. A working line, such as an inlet, pressure, or return, is shown as a solid line. Working lines with arrows show direction or flow. For instance, this line indicates oil flows in only one direction, while this line shows flow in either direction. Pilot or control lines are broken into long dashes, while drain lines for leakage oil are broken into short dashes. A flexible line is shown as an arc between two dots and is always represented by a solid line. Quite often you will see an enclosure outline that indicates that there are several symbols that make up a component assembly, such as a valve or a valve stack. The enclosure outline appears like a box and is broken with dashes on all sides. The shortest distance between two components that are connected is a straight line. There are lines that cross other lines but are not connected. Here are 3 examples of crossing lines that are not connected. Lines that are connected are shown with a dot that represents the connection, or shown as a T connection. The dot connection is the most commonly used when drawing schematic diagrams. There are many basic designs of pumps. A simple fixed displacement pump is shown as a circle with a black triangle that is pointing outwards. The black triangle is like an arrowhead and points in the direction that the oil will flow. If the pump is reversible or designed to pump in either direction, it will have 2 black triangles in it, and they will be opposite each other. A variable displacement pump is designated by drawing an arrow through the pump symbol at 45 degrees. To indicate a variable displacement pressure compensated pump, a small box with an arrow in it will be added to the side of the pump symbol. If the pump is controlled by a lever or a pedal, it will be shown on the side of the pump. A drive shaft is shown as 2 short parallel lines extending from the side of the pump. If a curved arrow is shown on the drive shaft, it will indicate the direction of rotation. Hydraulic motor symbols are circles with black triangles, but opposite a pump, the triangles point inward to show the motor is a receiver of oil. 1 triangle is used in a non-reversible motor, and 2 triangles are used for a reversible motor. This simple schematic diagram is shown with a hydraulic motor connected to a hydraulic pump. Remember, the position of the triangle will tell you if the symbol is a pump or motor. A cylinder symbol is a simple rectangle representing the barrel. The piston and rod are represented by a T that is inserted into the rectangle. The symbol can be drawn in any position. If the cylinder is single acting, there is only 1 port shown on the symbol. The port is shown on the end of the cylinder that receives pressurized fluid, and the opposite end of the cylinder is left open. A double-acting cylinder symbol has both ends closed and has 2 ports on the symbol. While a double-end rod cylinder has a rod extending from each end of the rectangle. Some cylinders have cushions built into them. The cushion slows down the movement of the piston as it nears the end of its stroke. Cylinder cushions are shown as a smaller rectangle on the piston. If the cushion has an adjustable orifice, a slanted arrow is drawn at 45 degrees across the symbol. The basic pressure control symbol is a square, which is called an envelope, with external port connections and an arrow inside to show the oil passage and direction of flow. Usually this type of valve operates by balancing the oil pressure against a spring. So a spring is shown on one side of the symbol and a pilot pressure line on the other side. A normally closed valve, such as a relief or sequence valve, is shown with the arrow offset from the ports and toward the pilot pressure line side of the square. The spring holds the valve closed until the pilot line oil pressure is greater than the spring pressure. Mentally visualize a buildup of pressure in the pilot line and the square moving over, compressing the spring. This would allow oil to flow through the valve. If your visualization was correct, the valve would look like this. A normally open valve is shown with the arrow connecting the two ports. It closes when pressure overcomes spring force. Mentally visualize a buildup of pressure in the pilot line and the square moving over, compressing the spring. The oil flow through the valve is now blocked. The valve would look like this if your visualization was correct. In this example, a relief valve is shown as a normally closed symbol connected between the pressure line and the reservoir. The flow direction arrow points away from the pressure line port and toward the reservoir. This shows very graphically how a relief valve operates. When pressure in the system overcomes the valve spring by way of the pilot line, fluid flows from the pressure line through the relief valve and then to the reservoir. This is how the valve would look if you visualized it correctly. Now let's visualize how a pressure-reducing valve works. A pressure-reducing valve is shown as a normally open symbol in a pressure line. This valve works opposite of a relief valve, since it senses outlet pressure versus inlet pressure. As the outlet pressure builds, it works against a predetermined spring force. As the spring force is overcome, flow through the valve is modulated or shut off. The normally closed symbol is also used for a sequence valve. The inlet port is connected to a primary cylinder line and the outlet port to the secondary cylinder line. When the piston in the primary cylinder reaches the end of its stroke, the pressure in the supply line increases. The sequence valve is also connected to the supply line, and it also feels the increase in pressure. As pressure increases, the square and directional flow arrow moves over, connecting the inlet and outlet ports, allowing fluid to flow to the secondary cylinder. This is the symbol for a simple one-way check valve. When oil pressure is applied to the right side of the ball moves away from the V, and oil can flow past it. When oil pressure is exerted on the left side of the ball is forced into the V, and no oil can flow past it. The bypass valve is shown as a one-way valve with a spring on the ball end of the symbol. This shows that a pressurized flow will be necessary to overcome the spring force and allow flow around the ball. Now let's look at a more complex one-way valve. This one-way valve uses a multiple envelope or square for each position. Remember, all of the port connections are made to the envelope that shows the neutral condition of the valve. The envelopes show the flow conditions when the valve is shifted to that position. Mentally visualize a buildup of pressure on the right side of the valve. If your visualization was correct, the valve should look like this. A simple control valve has two envelopes if it is a two-position valve. The envelopes show the flow conditions when they are in one position. This schematic is showing that oil is being supplied to the rod end of the cylinder. Mentally visualize the directional control valve moved to the other position. Now, pressurized oil is being supplied to the piston end of the cylinder, and oil from the rod end of the cylinder is allowed to flow to the reservoir. Three-position valves will have a centered or neutral position. The centered position can be either open or closed to flow. The open center is usually used with a fixed displacement pump, and the closed center is usually used with a variable displacement pump. Valve spools can be controlled by levers, pedals, pilot oil, or electric solenoids, which are called actuating controls. These actuating controls are shown by symbols placed on the ends of the envelopes. The dashes here indicate that this valve is being controlled by external pilot pressure. Valves controlled by solenoids are shown with a small square with a diagonal line located at the end of the envelope. Other actuating controls, such as a pedal, use this symbol, while a lever is shown with this symbol. A black triangle in a small square indicates internal pilot pressure is used to assist the actuating control in moving the valve spool. This symbol is placed at each end of the envelopes between the actuating control and valve spool. To show that a valve is spring-centered, a spring symbol is placed at each end of the envelope. This schematic shows that an electric solenoid and pilot pressure assist are required to overcome spring force to move the valve spool. The basic flow control symbol is a representation of a restrictor. If the restrictor is adjustable, a slanted arrow is drawn across the symbol. The restrictor could be a special fitting with a small hole in it, or a small drilled passageway within a valve. Restrictors can be applied to meter out, meter in, and bleed off circuits. There are adjustable restrictors that are pressure compensated. That means that the size of the opening in the restrictor will change with increases and decreases in pressure. A perpendicular arrow indicates pressure compensation. If the restrictor has both pressure and temperature compensation, the symbol for a thermometer will also be shown. Filters, strainers, and heat exchangers are represented as squares that are turned 45 degrees and have the port connection at the corners. A dotted line in the opposite direction to the flow line indicates a filter or strainer. A solid line in the opposite direction with black triangles pointing out indicates a cooler. The symbol for a heater is like the symbol for a cooler, except the black triangles point in. Two sets of triangles pointing in and out indicates a temperature control unit. As you can see, the black triangles point in the direction that the heat is dissipated. Or in the case of the control unit, they show that the heat can be regulated. An oval with details inside indicate an accumulator. The details inside will tell you what type of accumulator it is, spring-loaded, gas-charged, or other features. The divider line indicates there is a separator between the charge and the oil. A hollow triangle indicates gas. A spring shows that the accumulator is spring-loaded. We have now covered some of the more frequently used symbols in a hydraulic system schematic. If you have any questions, please review the tape again and refer to the booklet, Hydraulic Symbols and Schematics.